Data analytics are fundamentals. This is the table of content. It's following the training manual, the curriculum that was sent earlier. So module unit 1 is understanding data analysis. 2, data collection method, data cleaning methods, joining versus concatenating. 5, exploratory data analysis, EDA, statistical data analysis, probabilities and data analysis, hypothesis testing in statistics, data transformation methods, machine learning in data analysis, data visualization methods. So we'll just run through this briefly. So unit 1 is understanding data analysis. Here we're talking about the key concepts and importance. So what is data analysis? You've heard that, perhaps you've had it over and over. So data analysis is a systematic process of inspecting, cleaning, transforming, and modeling data to extract useful insights, support decision-making, and enhance strategic planning. It involves identifying patterns, relationships, and trends within data sets to answer specific questions. So basically, it's a process that is systematic. When you see data, you first look at it, inspect, okay, what do you want to make out of this? Then you go through the process of cleaning, because if you don't clean it, you're definitely going to have errors, or if you're using it to make predictions, your predictions will be wrong. So you'll get errors, your predictions will be wrong. And if it's something that has to do with life, let's say it's in the health domain, and you're making a wrong prescription because your data is wrong, is not cleaned, it could cost someone his or her life. And even the medical doctor or the health personnel concerned could lose his or her license. So that is why this thing is very, very important. You go through inspecting it, you clean it, you transform it into the form that is needed for the kind of work you want to make it to be, then model it, then you can now extract useful insights. And what is the reason for all these things? Because you want to use it to support your decision-making process. It could be for a government. They want to know the rate at which people are leaving their country. Will be called to make perform data analysis in that aspect. So you need to get the data right. You can't just give fake data. You can't just guess. No, it has to be. You need to follow some process. So this is what data analysis is all about. So what are the importance? Like I said, informed decision making. It helps organizations make decisions based on data rather than intuition. You don't just say something off heart and say, no. It has to be based on data. So it helps to make informed decision. Then it improves efficiency. It helps in making predictions, predictive capabilities, in forecasting, all this weather forecasting, the work with data, forecasting sales, forecasting inflation in an economy, in an organization. So these are areas where data analytics finds its expression and is of importance. Competitive advantage. It provides businesses with insights to outperform competitors. You can't just go into any business. You need to do your findings. Okay, what are the data obtainable in this area? Then you can be able to scale through to compete effectively with your people who are in the same trade with you. So role of data analysis in decision making, like I said, identifies patterns, correlations, and influence key business strategies. Support risk management by analyzing past trends to anticipate future risks. This is the most common, maybe for me though, because you collect data and you're able to analyze for past trends so that you can be able to make decisions, then enhance customer understanding by evaluating behaviors and preferences. So what are the key concepts in data analysis? The types of data analytics. Doctor has spoken to us about this earlier. There's descriptive, that is summarizing past data to understand what happened. An example is a sales report showing monthly revenue trends. Diagnostic analysis, to explore why something happened by identifying cause. So it's more like cause and effect analytics. So you are diagnosing. An example is why customer churn increased last quarter. Why are customers leaving a particular network? Why are customers leaving a particular bank? Why are customers leaving a particular sales outlet? So you diagnose. Then the predictive analytics, using historical data and machine learning models to forecast future, is making predictions. You're not making predictions on maybe an intuition, but making predictions based on data. So an example is predicting sales for the next quarter based on past patterns. You could, for yourself, you could develop a system. Let me even call it a model of your spending patterns based of how much you are likely to spend in this month of March. The month of March, based on your past spendings. Maybe you spend so much on fuel, you spend so much on eating outside instead of cooking at home, having your meals at home. So you can be able to, based on your spending pattern, you can be able to make predictions. That is the predictive analysis. Then prescriptive, like a doctor suggesting, okay, based on this is what I suggest. So it suggests the best course of action based on data insights. Example includes recommending product discounts based on customer purchase behavior. So what are the types of data types? There is structured data, unstructured data, and semi-structured data. So structured data are organized data in form of databases, like your Excel tables, SQL databases. You'll be working so much with this. Doctor will put you through your databases, relational database aspect. So you need to know clearly when you see structured data and unstructured data. And there are times where the data might look structured, meanwhile it's unstructured. So it falls in between structured and unstructured. That is semi-structured. We'll come to that later. So what is unstructured data? They are raw data that lacks predefined formats, e.g. your social media posts, your images, videos, PDF documents. Then semi-structured is a mix of both structured and unstructured data, like your JSON files, XML documents. It looks structured, but somehow it is unstructured. So it's a combination of both. Then what are real-world applications of data analytics? We just picked 4, like in business, market analysis. You see inventory optimization to reduce costs and waste. In finance, you can use it to detect fraud using machine learning algorithms, instead of you manually looking at someone's, or if they give you a bank's account statement, you can be looking at a paper or just merely looking at the Excel document, but you wouldn't know what fraud is being perpetrated. But with machine learning, application of data analytics, you can be able to detect fraud, which we'll still talk about in the course when we get to the machine learning aspects. Then investment risk assessment based on market trends. Then the healthcare, it works in the area of healthcare such that predictive analytics for disease detection and prevention. You can use it to detect disease, protect mortality rates, makes a lot of findings of personalized treatments in education, measure student performance, analysis to tailor teaching strategies, institutional decision making for resource allocation. Then, okay, so institutional decision making for resource allocation. Are we still connected? Hello?
Yes.
Yes, sir.
Okay. Because I heard a sound. I thought maybe someone made a request, or could it be that someone was trying to join? Okay.
No, I was the
So
one
what?
who was disconnected and I joined.
Okay.
Yes.
All right, let me go back. So, I hope you're seeing my screen in presentation mode, right?
Yes, we can
Okay.
still see. Yeah.
Okay. So unit 2, data collection methods, techniques, and sources. So there's primary and secondary data sources. So definition of data collection. Data collection is the process of gathering information from various sources to be analyzed and used for decision making. It is a crucial step in data analytics, such that it ensures insights derived are based on accurate and relevant information. We keep saying it, you must work with data and accurate data. So what are the data sources we have? We have primary data source. Primary data is collected firsthand by researchers for a specific purpose, such as surveys and questionnaires, collect responses directly from participants, go for maybe an event or a training or workshop. Surveys and questionnaires are very, very important. And in the course of this training, you see you see how you can transform your questionnaires, even from unstructured data to structured, and make decisions based on that. So surveys, so interviews is one-on-one discussion for in-depth design, for in-depth insights. So experiments as control studies to test hypotheses, observations that's directly watching behaviors or patterns. That's a primary source. Then secondary data source is pre-existing data collected by someone else, often used for different purposes. So in case of primary, you collected the data firsthand. Then in the case of secondary, is the data collected by someone else, often used for different purposes. So just such as government reports, like census data, industry reports, that's market research studies, academic publications, like you go to search for research papers and studies, you didn't collect it firsthand, so it's a secondary data source. Then company databases like historical sales, customer records. Then data collection techniques.
Yes, sir.
So surveys and questionnaires is used to collect structured responses from a large audience. Questions can be open-ended or multiple choice. When you see some surveys or questionnaires, it can allow you to just really write, that's open-ended. Then if you're limited, you select boxes, pick from ranges 1 to 0, 1 to 5, 1 to 10, whatever. So some of the tools are Google Forms, Survey Monkeys, Typeform. These things are very, very important because these are things you'll be working with. Most of the times, you will not be presented with Excel document. You might have to be the one that will go and source for this information by yourself. You could be the one that will design the form and send the questionnaires outside or whatever. All you just need to know is you have to collect data. So another one is web scraping. This is very, very important. In the course of this, before we end, these are 8 weekends, we'll use web scraping. And that's when we'll now start working with some machine learning aspect as well. So web scraping, that's automated extraction of data from websites. We'll show you how to extract that, used for price tracking, maybe market research, sentiment analysis. Then tools, some of the tools include Beautiful Soup, Scrapy, Selenium. Like this web scraping is very, very important. I remember I was working somewhere, there was an election being held in the state capital of federal capital of Nigeria, Abuja. So the election was, journalists were on ground monitoring the election. They were sending in reports, and we, the ICT team, we were publishing it live. So we could see live reports from each polling unit. So it keeps updating after a few seconds. So those data keep updating. So, and in the case maybe where you cannot get such kind of data, let's say someone knows that, okay, there are journalists, reporters on ground who are gathering data, then they're sending it through their mobile phones to a server, and we are making sure that this thing is verified and we're publishing it. Someone else from another place was busy interacting, web scraping our website, then extracting data from it. And there are cases where you will need, let's say, like an election is just like the example I just cited. Like in Nigeria, we have a body called INEC. If they provide something like API, application programming interface, you could connect through their API and extract data. And in real time, you'll be making decisions, making inference from the data being sourced in real time. So API, that's application programming interface, it allows access to data from online sources and platforms. If you wonder why, how are they getting results in real time, meanwhile they are not at the polling unit? It could be through web scraping or API. So examples are Twitter API for social media, Open Weather API for weather forecast. So interviews and focus groups. This includes conducting interview with the person, maybe via phone, virtually, to gather qualitative insights. It will be through focus groups, allowing discussions among a selected group of individuals. Then sensor and IoT. IoT stands for Internet of Things. Most of us have gadgets that you can connect to remotely, and as they are connected, you are gathering information. You could be at your location and extracting data on your phone right there, and you could work with that data. So collected from smart devices such as GPS, wearables, or industrial sensors, used in real-time analytics such as traffic monitoring or healthcare tracking. So these are some of the techniques used to gather data. And we could give you an assignment to, okay, use web scraping, use API to go and source this data, analyze it, visualize it, then give us your report. So ensuring data quality. Why data quality matters? One of the reasons is poor data leads to incorrect conclusions and faulty decision making. So we cannot stop emphasizing the need for clean data, for quality data, because if you give a faulty data, your predictions or your analysis will be wrong. So it is very, very important. Then ensuring accuracy improves the reliability of insights and predictions, just like what I've said. So what are best practices for accurate data collection? One, as a data analyst, these are the things you need to put in mind. You need to define clear objectives. Know what data is needed and why. It's not all data you need. In fact, when you collect your data, it's not all the variables that are needed, but notwithstanding, at first, just have clear objectives of what data is needed. So number two, use reliable data sources. You need to verify credibility before collecting data. Just like the example I cited, where we know that the people who actually went to these polling units, polling booths, are journalists who are non-partisan. So we were sure that the data they were getting are not manipulated, they are not biased, they are not politically motivated to, or financially motivated to alter alter records. So when you know you're getting your data from credible sources, you should be sure that your analysis will be right. So use reliable data sources only. If you're getting data, let's say like the case I cited, getting data from reporters that we know are trusted, it's better that way than getting your data from party members or party agents who exaggerate, inflate records. So use reliable data sources. Then three, avoid bias. Ensure survey questions and selection criteria are unbiased. Check for completeness. Fill in missing values or request missing data. Five, ensure consistency. You need to standardize formats such as dates and measurement units. Make sure that these things are standardized. Your unit, if you're using centimeter, make sure it is consistent. Don't use centimeter and now use kilometer. It could give you an outlier It could make your it no it will make your findings wrong. If you are using Fahrenheit, stick with Fahrenheit. If you're using Celsius, use Celsius, so that just ensure consistency. Then unit 3, data cleaning methods, enhancing data quality for better analysis. So what are the importance of data cleaning? Why is data cleaning important? Data cleaning is the process of detecting, correcting errors, inconsistencies, and inaccuracies in data sets. High data quality ensures accurate analysis and reliable insight. We've mentioned that. The impact of dirty data on analysis. It gives misleading insights. There will be errors, inefficiencies, poor quality data increases processing time, decision-making risks. Unclean data can lead to costly business decisions. So imagine an organization, a multi-million dollar establishment, making decision based on faulty data, on wrong data, on unclean data, could lead to them losing millions. They could even go bankrupt. So you have to be careful, because you never can tell where you apply your skills. So key benefits of data cleaning: improves data accuracy and reliability. That's 1. It enhances efficiency in analysis and decision making. 3, it reduces redundancies and inconsistencies in data sets. Then we have key cleaning techniques. Doctor has mentioned this to you earlier on. Handling missing values. We have deletion. So that's removing rows or columns with excessive missing data. Imputation, that is replacing missing values with mean, median, or mode. Doctors talked about this, and we'll still talk about it in subsequent trainings. So removing duplicates, that's identifying and eliminating duplicate records to avoid redundancy. Then handling outliers, detection methods, box plots, standard deviation, and Z-scores. We still have treatment, that's removing extreme values or adjusting them based on business logic. So handling outliers handles that. Then standardizing and normalizing data. Standardization, that's converting data into a common format to maintain consistency. I remember the last training, doctor was showing you something about selecting a particular date format. So you could have a standard, convert your dates maybe to months, days, and year, or you start with year, months, or days. So standardization is important. Then normalization, that is adjust data values to fall within a specific range for comparison. Then an example is scaling numerical values between 0 and 1. Then transforming data for consistency, that is ensuring uniform column names, formats, and units of measurement. Unit 4, joining versus concatenating. This is combining data for enhanced analysis. So differences and use cases. Understanding data combination methods. In data analysis, combining data sets is a crucial step for comprehensive insights. The 2 primary techniques used for this are joining and concatenating. So you need to know the key differences between joining and concatenating. Talking about joining, what's the definition of joining? That is merging data sets based on common keys. Practically, you'll be shown this, but this is for your own keeping. So what is concatenating? That is stacking data sets on top of each other. So when we talk about matching data set based on common keys, maybe 2 tables have common keys, you can be able to match the data sets. But concatenating, that is stacking them on top of each other. That's the definition. Then when to use it, when to use joining and when to use concatenating. So you use joining when combining related tables with shared data. That's when you use joining. Then when do you use concatenating? When appending similar data structures. So if they are not of the same data structure, concatenating them might complicate your setup. So what are the common tools for joining? We have SQL, Excel. We look at all these things. In Excel, you have VLOOKUP, Power Query. In Python, we have merge function in pandas. That's an example for joining. Then for concatenating, we have Excel, Python, concat function in pandas as well. So what are examples of joining? That is merging sales data. Let's say, for an example, you're merging sales data with customer details using a unique ID. There are two tables, they have unique ID. Let's say their organization registration ID number. You know, these IDs are the same. So based on that, you can merge the two tables together. Then concatenating. And a typical example is appending monthly sales reports to form a yearly data set. So these are some of the key differences, and go back to these documents and to guide you. So use cases in joining is used when integrating customer data with sales transactions. Then concatenating is useful for aggregating multiple data sets of the same format, such as yearly records. The techniques in Excel, SQL, and Python. For joining, let's look at some of the techniques. So for Excel, use VLOOKUP or XLOOKUP to fetch data from another table. Then you use Power Query to merge tables. In SQL, use join statements, inner join, left join, right join, full join. An example is, I know you've not started SQL, but by the time you start, it will look strange to you. So like select customers.name, comma, orders.order ID. That's you want to select customer's name and the order ID from customers. You now specify inner join orders on customers, that customer ID equals orders of customer ID. Why you joining is because if they have if the customer ID from these tables, if they match, so you use the inner join. Then joining data, techniques in Excel, continuation, joining data using Python. In the first case, let me go back. We use Excel and SQL. Excel and SQL. So this time around, a typical example in Python could be you use the merge function. An example is you import pandas as PD. We'll talk about this one. DF, that's data frame. PD, this is the code for this. To join this data frame, you match them together, and you now print the matched function. So we need to put you through all these things so that it won't be strange to you by the time we'll go to Excel, we'll go to SQL and Python, and we'll start doing all these joining and concatenating. So concatenating now. So in Excel, this is a typical use in Excel. That's the formula, that's the code they use concatenate or text join for string merging, append tables manually or with Power Query. So for SQL, use concatenating, like you use union to stack data sets. You know, we told you that concatenating is about stacking data sets. So example is select all. When you see hash, it means all. Select all from sales underscore 2023 union, that is joining the two. Select all from sales underscore 2024, so that it should select all from this sales table. There's a table called data. Let me also data sets. In this case, might not be table. Select all from this data sets 20 sales underscore 2023 and sales underscore 2024. So it should match the two data sets together. So this is, you use union for that. That's concatenating them. Then in Python, a typical example is use concat function. So this is the code of how it's being applied. df1 equal pd dot data frame, parentheses, put the month, January, February, you match, you'll be able to concat, you stack these two tables together. Then you print now. The combined, you use a variable called combined underscore df to carry out this pd dots concat function. So it merges df1 and df2 together, then you now print the combined. That is its application in using Python, concatenating. Then choosing the right method. So you use joining when working with relational data sets that share a common key. We talked about joining, that it is used to join when you have common, they share common key. So concatenating, you use concatenating when stacking data sets with the same structure. They need to be of the same structure. Take note of that. Then unit 5, exploratory data analysis, EDA, understanding your data before modeling. So summary statistics and distribution. So understanding summary statistics provide a snapshot of data by measuring central tendency, dispersion, and distribution. So what are measures of central tendency? I believe in a secondary school or in a post high school, our high school, post high school, or whatever level of study must have come across this mean, median, mode. This is statistics. So mean stands for, mean is actually average. So it's a sum of all values divided by the count, while the median is the middle number, the middle value in a sorted data set. Then the mode is the most frequently occurring value. Then we have measures of dispersion. So we have variance, we have standard deviation, we have range. Please take note of all these things because we'll be using them in a machine learning application. So variance, it measures the spread of data points. Then standard deviation is the square root of variance, indicating how much data deviates from the mean. Then the range is the difference between the maximum and the minimum values. So so looking at data distributions now, for normal there's normal distribution, there's skewed distribution, then there's kurtosis distribution. So what is normal distribution? It is symmetrical bell-shaped curve. It is common in natural data sets. What is skewed distribution is a symmetrical data distribution. Right skewed, it can be right skewed or left skewed. Then kurtosis measures the tiltedness of the distribution. Talk more about this later, but this is just to introduce you to some of these concepts. So why these metrics matter? So why do they matter? It helps in identifying trends and anomalies. Data analysis is all about predicting, identifying trends, find out why, cause and effect, talk about predictive, descriptive, explorative. So it helps in identifying trends and anomalies. Then it's essential for selecting appropriate analytical models. Then guides decision making by summarizing data effectively. So identifying patterns and anomalies. We talk about detecting patterns in data. So exploratory analysis involves visualizing and summarizing data to uncover trends and relationships. We have time series trends, that's identifying seasonality and cyclic behavior in data. We have correlations, that's examining the relationships, examining relationships between variables using scatter plots and correlation coefficients. We'll talk about this much later. Using scatter plots diagram. We have identifying anomalies, that's outliers. Outliers can distort analysis and must be identified and handled properly. So we have methods for detecting outliers. We have box plots. It highlights values based beyond the interquartile range. We have z-scores, measures how far a value is from the mean in terms of standard deviation. We have standard deviation method, which is very common. Values outside ±3 deviation are often considered outliers. So identifying patterns and anomalies. We have visualizing data for insights. So we have histograms, which shows you frequency distributions. We have scatter plots, helps you identify correlations. We have box plots, it helps you detect outliers and its spread. So why EDA is crucial? Exploratory data analysis is crucial because it ensures data is ready for modeling and analysis. It helps refine hypotheses and make informed decisions. It supports data-driven storytelling by uncovering key insights. We move to Unit 6, statistical data analysis. That is understanding statistical techniques for data insights. So let's compare. We have descriptive versus inferential statistics. So what is descriptive statistics? Descriptive statistics summarizes and presents data in a meaningful way. Descriptive statistics, so describing something in a meaningful way. Describing data, summarizing it in a meaningful way. They help in understanding patterns and trends in data set without making inferences beyond the collected data. So you don't make inferences beyond the collected, you work based on the collected data. So we have measures of central tendency that we've talked about, mean, median, mode, then measures of dispersion, range, variance, deviation, then data visualization techniques for descriptive statistics. We have histograms, box plots, and bar charts. Inferential, we talked about descriptive now earlier, so we're going to inferential statistics. Inferential statistics help make predictions and generalizations about a population based on sample data. This is done using probability theory and hypothesis testing. So key concept in inferential statistics, there's the population, that is the whole data itself. Then the sample, you pick a set, like a data set from a whole collection. So analyzing a sample to infer conclusions about a larger populations. So you need to compare so some of the concepts involves comparing the whole population with the sample. So we have confidence intervals. That's a range of values likely to contain the true population parameter. Then we have margin of error, a measure of uncertainty in an estimate. I'm sorry we are going this lane because we don't want it to be half-baked. So you might find yourself applying these things later. Even if you're not going to apply it, there's no crime in learning this. So why understanding both is important? Why understanding descriptive and inferential is important? Descriptive statistics helps summarize data efficiently, while inferential statistics help make predictions and guide decision making. Both methods work together in analyzing real-world data sets. I keep telling why are these things important, or why learning all this. Could be employed to work as a data analyst, and you're presented some of these things. You should be intelligently bold to talk about these things based on your training. So statistical methods, we have correlation analysis. Correlation measures the relationship between two variables. We have positive correlation, we have negative correlation, we have no correlation, we have present correlation coefficients. So positive correlation is described as one variable increases, the other increases as well. But for negative correlation, as one variable increases, the other decreases. Then when there's no correlation, there's no relationship between the variables. Then Pearson's correlation coefficient, that is represented as R, it measures the strength and direction of a relationship between two continuous variables. That is between -1 to, that is -1 to +1 to 1. Then regression analysis. Regression models help predict the relationship between a dependent variable and one or more independent variables. We'll practicalize this when we get to our machine learning aspect. So types of regression. We have linear regression. It predicts a continuous outcome using one independent variable. But when you have more than one independent variable, we have what we call multiple regression. Then logistic regression is used for classification problems. That is binary outcome, either 1 or 0, yes or true. And true or false, yes or no. So hypothesis testing. Hypothesis testing determines whether an observed effect is statistically significant. Steps in hypothesis testing: define null hypothesis, define alternative hypothesis, use a significant level, calculate the test statistics, compare with critical value / p-value. Then common statistical tests include t-test, which compares means of two groups. Chi-square or chi-square test checks the association between categorical variables. We have ANOVA. That's an acronym for analysis of variance. It compares means across multiple groups. The t-test, like we talk about, compares means of just two groups. Then t-test checks the association between categorical variables, while ANOVA compares means across multiple groups. So why is statistical analysis important? One, it helps in decision making based on data trends. Two, it provides scientific backing for business and research conclusions. It identifies relationships, patterns, and predictions in data sets. Unit 7, probabilities and data analysis. That is understanding the probability theory for better data insights. Probability theory basics. What is probability? Probability is the measure of the likelihood of an event occurring. It helps in making informed predictions based on available data. We have a general formula for probability, which is represented by P, is equal to the number of favorable outcomes over total number of, divided by total number of outcomes. So formula for probability is number of favorable outcomes divided by the total number of outcomes. So basic probability rules. Rule 1, that's range of probability. You must know the range of probability is between, it ranges between 0 and 1. So you can't have anything outside this range. So you can't say probability of 1.5. No, it's between 0 and 1. That's probability. So rule 2 for probability, that is a sum rule. The sum of probabilities of all possible outcomes in a sample space is 1. Then rule 3, complement rule. The probability of an outcome not occurring is 1 minus the probability of its occurring, of the probability itself. Rule 3, let me come again. That's complement rule. The probability of an event not occurring is 1 minus the probability of it occurring. Types of probability. We have classical probability. It assumes equal likelihood of outcomes. E.g., if you're rolling a fair die, the probability is, the likelihood is equal. So empirical probability, it is based on observed data rather than assumptions. Then we have subjective probability based on personal judgments or expert opinions. Maybe someone who's been a doctor who's been medical doctor who's had experience over the years. He could make predictions probability based on his or her expert judgments. Expert opinions based on personal judgments. So probability distributions. We have probability distribution describes how values of a random variable are distributed. We have discrete probability distribution. We have continuous probability distribution. Let's proceed. Applications of probability in data science. 1, predictive analytics. Probability is used to make predictions in various domains. For example, in stock market, you can use it to estimate the likelihood of stock price changes. In e-commerce, you can make prediction about customer purchases based on past behavior. Customers purchase this, so you can use it to make prediction. That's predictive analytics. Bayesian probability. Bayesian probability is used to update probabilities as new evidence becomes available. So when you begin to have more evidence, the probability is updated. That is Bayesian probability. An example is spam email detection. That is adjusting the probability of an email being spam based on certain keywords. You know, like antivirus manufacturers, they keep detecting new viruses, new trojans, so they keep updating their records. So this works in this kind of domain. So probability in machine learning, so naive Bayes classifier, a probabilistic algorithm for classifying tasks. So we'll get to that. Then hidden Markov models, HMM, it is used in speech recognition and time series forecasting. So like we said, you might find yourself in machine learning, you might find yourself in predicting stock records, you might find yourself in the health domain, different domains, community service. So all these things are necessary for you. So risk analysis and decision making. Probability is crucial in evaluating risks. We have, for example, in medical testing, understanding false positives and false negatives. In insurance, estimating accident risks based on past data. Unit 8, hypothesis testing in statistics. That is understanding the role of hypothesis testing in data analysis. Key concept of hypothesis testing. What is hypothesis testing? Hypothesis testing is a statistical method used to make inferences or draw conclusions about a population based on sample data. Talk about sample and whole population the other time. It helps to determine whether a certain assumption about data is statistically significant. What are the key terms in hypothesis testing? We have null hypothesis, we have alternative hypothesis, we have significant level, we have p-value, we have type 1 error, we have type 2 error. By the time we get to this, we'll know more about that, but let's just move further. So common hypothesis tests in data analysis, we have t-tests, that's comparing two groups. We have chi-square tests, just like we spoke about the other time. We have ANOVA, we have regression analysis, we've talked about it as well. Then steps in hypothesis testing. Step 1, you state the null and alternative hypothesis. Step 2, choose the significant level. Select the appropriate statistical test. Step 4, calculate the test statistic and p-value. Step 5, compare p-value with alpha, then make a conclusion. Real-world application of hypothesis testing. In business analytics, an example is testing if a new marketing campaign leads to higher conversions. In healthcare, evaluating the effectiveness of a new drug. In finance, analyzing if a change in interest rates affects stock prices. In e-commerce, a real world application is assessing if free shipping increases purchase rates. So we've talked about its application in business analytics, in healthcare, in finance, and in e-commerce. Find yourself in any of these domains later, so you know the hypothesis testing finds its way there. So data transformation methods, that's unit 9, techniques for preparing data for analysis. Introduction to data transformation. Definition. What is data transformation? Data transformation is the process of converting raw data into a structured, usable format to enhance analysis and decision making. So raw data needs to be converted into a structured, usable format to enhance analysis and decision making. Most of the times, especially machine learning, it works with structured data. You can have your documents in PDF, in email, in pictures, images, but a process needs to occur to transform such unstructured data into structured data before machine learning will work on it. You might not notice this. Maybe you're using a machine learning application because it works so fast. The processing speed is so fast because the servers that are controlling these machine learning applications, they are so fast with high computing resources. So, like I said, Data transformation is the process of converting raw data into structured and usable format to enhance analysis and decision making. So what is the purpose of data transformation? Improves data quality by handling missing values, duplicates, and inconsistencies. It prepares data for modeling and visualization. It enhances data compatibility across different tools and platforms. Common data transformation techniques. We have normalization, that is scaling values to a range in 0 to 1 to ensure uniformity. Standardization, adjusting data to have a mean of 0 and a standard deviation of 1 for better model performance. Aggregation, summarizing data, you calculate, for example, calculating total sales by region, encoding categorical data, that's converting text-based categories into numerical values, handling missing values, removing incomplete records, imputing missing values using mean, media, or predictive modeling. Data transformation in Excel, SQL, and Python. I hope we're still connected. Hello?
Yes, we are.
All right. Okay. So data transformation in Excel, SQL, and Python. Like in Excel, we have using functions like text, date, subtotal, and VLOOKUP for transformation, applying Power Query for advanced transformation. In SQL, using case statements like cast, convert for transformation, applying group by, having for. In Python, we have libraries. We'll get to that in subsequent trainings, using Pandas library for data manipulation, utilizing scikit-learn for scaling and encoding data. Feature engineering is very important, and transfer and data transformation. What is feature engineering? Feature engineering involves creating new variables or modifying existing ones to improve model performance. Whatever you do to make sure that your model is improved, feature engineering is one of those things you do. Creating new variables or modifying existing ones just to improve performance of your model. So what are the techniques? We have creating interaction terms between variables, extracting date time components, e.g. day, month, year, then transforming skewed data using log, square root, or power transformations. What are the importance of data transformation in machine learning? It prepares raw data for predictive modeling. It improves algorithm accuracy by ensuring consistency in feature scales. It reduces bias and variance, leading to better generalization. Unit 10, leveraging AI for advanced insights. Introduction to machine learning. So what is machine learning? Machine learning is a subset of artificial intelligence that enables systems, you can call it computer, to learn from data and improve performance without being explicitly programmed. We'll talk about this much in our subsequent trainings. When we say without being explicitly programmed, in the past, before the advent of, before the advent or the widely acceptability and there's much research that is being done today, you will need to write codes, lengthy codes, if these, then, for, while, a lot of conditional logics. But now with the advent of machine learning, you don't need to write more. You might still put in a little bit of code, but not as it used to be before, that for every single task you need to write code. But this time around, machine system learning from your data, being able to learn your patterns, just like the example I cited earlier, for your spending, what you spend on groceries in a month, what you spend on fuel for the month, what you spend on housing, what you spend on gifts giving to people. You understand? There's a way you can develop a machine learning, just simple application model using an algorithm to build a model such that you can be able to track your spending and predict how much you're likely to spend the next month, or how much is you are likely that will likely go to a certain category in the next month. So normally you're supposed to write codes, but because this time around the machine learning model will now learn from your data, from your spending habits, and be able to make predictions. So that is it. That's what we call machine learning from data. Data needs to be available. So the more availability, the more data you have available at your end from your spending habit, from your spendings, the more intelligent the machine learning model becomes. So why is machine learning important in data analytics? It automates data-driven decision making. It detects patterns and trends beyond human capabilities. I just cited a very typical example, a small example from your own spending. So imagine bank transactions of a very large bank that spans across different continents. You understand? So they could there are machine learning models, applications that have been built to be able to detect patterns, anomaly, maybe patterns of fraud. It will just trigger and just alert that there's fraud likely going to happen. It can mitigate, it could show in advance, it could even detect past fraud. So that's what machine learning does. So it enhances predictive capabilities in analytics. I told you it automates, detects patterns and trends beyond human capabilities. If there's a fraud going on in 5 different countries, how will you have known? But machine can deploy a machine learning model that will be able to track that and flag such transactions. So key concepts in machine learning, we have supervised learning, that is model learning from labeled data. I'll come back to these. Then we have unsupervised learning, that is model identify patterns in unlabeled data. We have reinforcement learning, model learn by receiving feedback from interactions. So when we say labeled data means you already know like an outcome. Unlabeled means you don't know outcome. Let me give you a typical example like the banking industry for fraud detection in this case. When we have, when a bank gives, you register with a bank, they have your details, your name, your phone number, your contact address, the day you made the transaction amount, the balance you have on your account. Then for that singular transaction at the end, they could note that maybe let's say the end record, there could be a column that states, okay, it is legitimate transaction. The transaction is legit. Then for each record of different transactions of different people, they can at the end they can put fraudulent. So let's say it's either legit or fraudulent. When you now have a column like that that specifies legit or fraudulent, that is a labeled data. But when you don't have a column that specifies that, that is unlabeled data. So supervised learning, it involves model learning from labeled data. We have some kind of techniques such as regression and classification. Then for supervised learning, model learns from unlabeled data. An example is clustering dimensionality reduction. We'll come to that. This is just introduction. Then reinforcement learning. Model learns by receiving feedback from interactions of such data. So machine learning applications in data analysis, we have predictive analytics, forecasting trends, e.g. sales predictions, anomaly detection, that is identifying fraud, errors, or irregularities in data sets. Then we have recommendation systems, that's personalized content suggestion, in platforms like Netflix, Amazon, your Facebook requests, suggesting friends that you should add up to you. You go to buy books, it's suggesting that why not add this other book. There are some metrics used in doing that. We'll get to that later. We have natural language processing, that is sentiment analysis, chatbots, and text summarization. These are some applications of machine learning in data analysis. So you could find yourself in any of these domains and you get to apply this later. So machine learning tools for data analysis. We have Python libraries. We work a lot with scikit-learn. So it's the basic machine learning model. We have basic machine learning models like classification and regression, which is common with scikit-learn. We have TensorFlow and PyTorch, which is for deep learning. When you hear deep learning is another level of machine learning. It's more complex or more complicated, a deeper learning than the normal machine learning. We have pandas and NumPy, that's for data pre-processing. We'll work with that as well later. Then another machine learning tools for data analysis, we have Power BI and AI integration. So AI-powered visualizations, through that also as well. Automated insights for data exploration. Under Excel and AI features, we have forecasting trends using built-in machine learning models, data analysis through Power Query. Then we have challenges. What are challenges in machine learning for data analytics? We have data quality. Machine learning models require clean and well-structured data. Like I told you, machine learning works with structured data. If the data is unstructured, it will first work on it and make sure it is transformed into a structured one. Then we have bias and fairness. You need to ensure ethical practices. If we go further in AI, you need to be taught, maybe in machine learning, we also let you know of some ethical practices that needs to be involved. Then we have a computational cost. As advanced machine learning models require significant resources. Most machine learning tasks are done on high-end servers on the net, not necessarily on your computer. Your computer can just be for practice, you rehearse some things, but the main computation are done in the cloud servers mostly, or servers that are high-end servers. So future of machine learning in data analytics, we have automating machine learning models, selection and tuning. That's the extent we are going now. So, things are becoming easier. So it's one of the feature to automatically automate your model selection and tuning. So explainable AI, that is making AI decisions more transparent. Presently, AI is still not as transparent as it should be. Like the ChatGPT you have, ask some questions, it will give you answers. Normally you feel I'm supposed to tell me what happened, what's the logic behind this, how you was able to generate such questions, where did you get these things from, So explainable AI for every maybe AI generated image or AI generated voice, as part of the ethics in AI, you're supposed to know that this is AI generated. And I think Chrome is doing such. When you type in some questions, because they need to be compliant as well, type in some questions on Chrome and some other applications, it will tell you that this is AI generated. Then now still bring other searches. So that's what explainable AI is, making AI decisions more transparent. Let you know that this is where you sourced for this, not that something has been mixed and you won't know the difference between auto-generated and the real. So we have AI augmented data analytics, that's seamless integration of AI-powered insights into business intelligence tools like your Power BI, your Tableau. AI, that's the future, integrating seamless integration of AI insight into those tools. Presently, we have AI-powered features, but it should be seamless. That's the future of AI. So Unit 11, which is the concluding unit for the module 1 here, data visualization methods, that's communicating insights through visual representation. We've been talking, you need to be able to see, that's the essence, so it will look abstract. So importance of data visualization, that's definition. Data visualization is the graphical representation of information and data to make complex patterns and trends easier to understand. You can talk, but when it's not being visualized, it doesn't really make sense. It says picture speaks louder than words. So why visualization matters? 1, it enhances data interpretation and storytelling. 2, it helps identify trends, outliers, and relationships. 3, it makes data-driven decisions data-driven decision making more accessible. It engages stakeholders through intuitive graphics. Let's say you're working in an organization, you're the data analyst, or you are in a team. We can be talking, telling them, okay, we made 40% sales last year. This year we have a fall by these, but they don't really grasp what you're saying. But if you're able to present it visually, you say, okay, they see that, okay, this histogram, this graph, this one is more than this one is higher, this one is lower. They can be able to, you can engage them through intuitive graphics. So common uses of data visualization in business performance tracking, market trends analysis, scientific research presentation to present your facts. So common data visualization types. We have bar charts. You've already been working with that in Excel, just to prepare you, because you still work more with that in using other tools, which might even be more interactive. So we have bar charts that's comparing categorical data easily. We have line charts to show trends over time. We have pie charts. We have scatter plots. We have heat maps. We have histograms, which shows frequency distributions. Then what are the tools for data visualization? We have Microsoft Excel, basic charts, pivot charts, and conditional formatting could be found there. We have Power BI and Tableau, which is an advanced interactive dashboards and business intelligence reporting. Although our focus will be on Power BI, Tableau is another wonderful tool. It is more advanced and visualization tool, depending on your level of need and what you really want to get. So we have Python. We're using tools like Matplotlib, Seaborn, Plotly. These are customized details and dynamic visualizations. For customized details and dynamic visualizations, we have SQL integration with Power BI tools as query-based visual reporting for databases. So what are some best practices in data visualization? One, you choose the right chart type. You match visuals to the data and insights. Two, you should ensure data accuracy. Avoid misleading visuals with improper scaling. Three, highlight key insights. Direct attention to the most important data points. Four, we have you should use consistent formatting. That's maintain a professional and readable design. Don't just be carried away by the looks. Maintain professional. Let it not be childish. So let your formatting be consistent. Then number five, keep it simple and clear. Avoid unnecessary complexity. These are some best practices in data visualizations. So you can see on the left-hand side here, you have some visualizations. So make it simple and something that people can easily comprehend and understand. So conclusion for module one for this. So for data analytics fundamentals. So in this module, we have established a strong foundation in data analytics by exploring key concepts, techniques, and real-world applications. We cover the different types of analytics: descriptive, diagnostic, predictive, and prescriptive, and their impact on decision-making. Understanding how to collect, process, and analyze data is essential for deriving meaningful insights. As we move forward, the next modules will build on this foundation with practical skills, tools like SQL, Power BI, and Python. We started with Excel. By applying these skills, you will be equipped to transform raw data into actionable insights, driving informed decision-making across various industries. Thank you so much. My name still remains Stanley Olaleke. I'm the director of Mexibog Innovation Hub, Abuja, Nigeria. Thank you so much.